prime factors, we are looking for prime numbers which multiply together to give the number we are looking for. The easiest way to explain what this means is just to show you. So we'll start off finding the prime factors of 54, and we'll leave plenty of space to do this calculation. So what we have to do at each point is ask ourselves the question, which two prime numbers multiply together to make the number we're looking at. So with 54, which two prime numbers multiply together to make 54. So first thing to notice is that it's an even number, so we can divide it by 2, and 2, of course, is a prime number. So if I divide 54 by 2, half of 50 is 25, half of 4 is 2, 25 and 2 is 27. Isn't a prime number, that doesn't matter at this point. We're just looking for any two numbers which multiply together to make 54. Now we're going to repeat the process with the two new numbers we've found. So we will look at 2. 2 is a prime number, so we're going to finish our tree diagram at the 2, and we'll come back to that later. Now looking at 27, I want two numbers which multiply together to make 27. So it's in the 3 times table, it's 3 times 9, 3 times 9. And then we're going to repeat the process again. So looking at 3, 3 is a prime number. Again, we'll come back to that later. And 9 is not a prime number, so we want two numbers which multiply together to make 9, which would be 3 times 3. Now, we've already discussed 3 being prime numbers, so the tree diagram ends at these points. No more numbers left in the diagram to split apart. So this is going to give us the first part of our final answer. 54 is 2 times 3 times 3 times 3. And if you multiply together those 4 numbers, the 4 prime numbers that came out of this method, out of the diagram, they will give you 54. Now, rather than write out a long list like that, we can improve this. We can write 2 times 3, and because we have 3 3's, we'll write 3 to the power of 3, just to keep things short. Now, for question 2, we're going to follow up the same process, so I'm going to write down 77. And I think of two numbers which multiply together to make 77, and we have a repeated number, two-digit number, so it'll be 11 times table, so 7 times 11 will make 77. Now repeat the process for the two new numbers. 7 is a prime number, so we can't split that into two numbers that multiply. And 11 is also a prime. We finished our tree here already, and we have our answer. 77 is 7 multiplied by 11. Now, these diagrams take up quite a lot of space, so I'll have to clear the screen before I continue. So just pause the video now if you want to spend a little bit more time looking at these two diagrams. Moving on to question 3, we have 38. Find two numbers which multiply together to make 38. Now, there might be more than one answer here, and that's fine. You'll get the same solution, but we should start with the smallest number just because it's a little bit easier. So 38, because it's an even number, we can divide it by 2. So what is 38 divided by 2? Well, half of 30 is 15, half of 8 is 4, 15 and 4 is 19. So then moving on to new numbers, we know that 2 is a prime number, so the tree stops there. And with the 19, 19 is also a prime number, so the tree stops on that side as well. If you're not sure if 19 is a prime number or not, try dividing it by 2, by 3, by 5, by 7. And if you get no solutions, then it can only be divided by itself and 1, and it's a prime number. So our answer, 38, is 2 multiplied by 19. Moving on to the next question, we have 63. So which multiply together to make 63. Now it's not even, but we might be able to divide it by 3, so let's try that. So 60 divided by 3 is 20, 3 divided by 3 is 1, so that'll give me 21. And let's just check this works. 3 times 21 is 63. Now we repeat the process with our two new numbers. So 3 is a prime number, so we're going to stop that branch of the tree there. And then 21, that's in the 7 times table, so I can divide it by 7, and 7 times 3 is 21. Now repeat the process again for our two new numbers. 7 is a prime number, it stops there. And we already know prime number, so that part of the tree stops there as well. Now all branches of the tree have stopped. We can get our final answer. We have two threes, so that'll be 3 to the power of 2. Power 2 just representing that I'm multiplying by two threes. And then we have our 7. And again, if you're not sure, try typing into a calculator 3 squared times 7 or 3 times 3 times 7. This should give you 63. Now moving on to 45. I need two numbers together to make 45. No, it's not even, so I can't look at 2, but it does end with a 5. And if we end with a 5 or a 0, we know that we can divide by 5. And 45 divided by 5 is 9. So repeat the process with our two new numbers. 5 is a prime number, so that half the tree stop. And 9 is not a prime number. 9, we can split it into 3 times 3. Now, we already know that 3 is a prime number, so the trend here, and we got the final answer. So starting with the smallest numbers to the largest numbers, we have two threes, so 3 to the power of 2, and we have 1 5, so 5 to the power of 1. And again, 3 squared times 5 will give us 45. Now, moving on to larger numbers, the method is exactly the same. We're just going to have a longer diagram to work with and more steps. So we have 175. We are looking for two numbers which multiply together to make 175. And right away, you should be able to see that the last number is a 5, so we should be able to divide by 5. 5 times what is 175 is the question, and if you're not too sure about that, just come over to the side, start a bit of working out, and do a bus stop method division. Don't try and do it in your head, it'll be faster this way. So how many 5s go into 1? 0. Carry the 1. How many 5s go into 17? 3. Carry 2. And how many 5s go into 25? 5. So you can see that 5 times 35 makes 175. Now repeat the process for the two new numbers. So we know that 5 is a fraction of the tree, and that'll form part of our answer. 35, again, it ends in a 5, so we know that we can divide it by 5, and 5 times 7 makes 35. Then repeating the process for these two new numbers, so we've got another 5, which we know is prime, and we have a 7 with prime number. We have no branches left on our tree, so we have a final answer. We have two 5s, so 5 with a little 2, 5 to the power 2, and we have 1 7, and there's our final answer. You can check it. If you type into a calculator, for example, 5 squared times 7, you should get 175. Moving on to question 2, I'm just going to start work on the part of the page that has the most space left because these diagrams are quite large, and I'm going to take 224. I'm going to try and split it into two numbers which multiply together to make. Now, the easiest method is probably to recognise that it's an even number, and if you do have an even number, we can always take out 2 as a factor, and then we can halve the number to get our other number. So 224, half of 200 is 100, half of 24 is 12, so we'll have 112. We know that 2 is an even number, That's one of the reasons why this method's so easy. You're halving, which is quite an easy calculation normally, and that 2 is going to be a prime number. Now looking at 112, we're going to follow the same method, split it into 2 numbers. It's even. Let's divide it by 2. Half of 100 is 50, half of 12 is 6, so that will give us 56. And we know that that 2 is a prime number. Repeating the method again for 56, it is still an even number, so I'm dividing by 2. Half of 50 is 25, and half of 6 is 3, so that will give me 29. I know that 2 is still a prime number. And then looking at 29, it doesn't end in an even number. I can't divide it by 2. It's not in the 3 times table. It's not in the 5 times table. It's not in the 7 times table. So now we have our final answer. We have 3 2's. So 2 to the power of 3. 2 times 2 times 2. And we have 29. Now, I don't think I have enough space for the next question, so I'm going to clear the screen. So again, pause the video if you want to have a little bit more of a look at these diagrams. So now I've got plenty of space, let's move on to question 3. We have 114. From the same method, we're going to split it into 2 numbers, which multiply together to make 114. It's an even number, so we'll start off by dividing it by 2. So half of 100 is 50, half of 14 is 7, so I'll have 57. 2 is a prime number, that stops there, and 57 isn't a prime number, so we're going to carry on and repeat the process, splitting it up into 2 numbers. Again, if you're not quite sure how 57 is going to work, well, let's try dividing by 3 first. So we'll do a bus stop method. How many 3's go into 5? 1. Remains 2. How many 3's go into 27? 9. So 57 would be 3 times 19. And then both 3 and 19 are prime numbers. So we're at the end. Our final answer is all the prime numbers multiplied together. So we have 1, 2, we have 1, 3, and we have 1, 19. Moving on to question 4, we have 2 numbers that multiply together to make 147. Now, it isn't an even number, so I can't divide it by 2. So let's see if we can divide it by 3. So let's do the bus stop method and double check. If you have a calculator, that's fine. And in the exam, it could happen either way. But if you do have a calculator, you might as well use it. Without a calculator, we'd say how many 3's go into 1? 0. Carry the 1. How many 3's go into 14? Well, 3 times 4 is 12, and we'd have remainder 2. And then how many 3's go into 27? Oh, that works. 3 times 49 is 147. We know that 3 is a prime number. And then you should recognize 49. 49 is a square number. It is 7 times 7. So we can split it up times 7. And both of those are prime numbers. So again, we are at the end of our tree. And we have our final answer. 147 is 1, 3 times 2 sevens with a power 2, just showing us that we're multiplying by 2 sevens. Now, I've run out of space, so we need to clear the screen again. So if you want to spend some more time looking at these diagrams, please pause the video. So moving on to the last question of the medium section, we have 156. Again, it's an even number, so we can divide by 2. And then the easiest way to find out what 156 divided by 2 is is probably to do a bus stop method again. So how many 2's fit into 1? 0. Carry the 1. How many 2's fit into 15? Well, 2 times 7 is 14, which leaves us with 1 left over. And how many 2's go into 16? That would be 8. So 156 is 2 times 78. We know that 2 is a number, and since 78 is even, we know it's not prime, and we're going to be able to divide it by 2, which is the only even prime number. So half of 70 is 35, half of 8 is 4, so 35 and 4 is 39. Again, the 2 is a prime number. And then 39, I think we're going to be able to divide this by 3. So 30 divided by 3 is 10. 9 divided by 3 is 3. So that'll give me 13 altogether. 3 is a prime number and 13 is a prime number. And all that's left is to write the final answer. We have 2 2's, 2 to the power of 2. We have 1 3. And we have 1 13. So 2 squared times 3 times 13 is 156. Now, throughout this video, you might have been thinking, well, what do prime factors actually mean? What's the point of finding them? So now, for the hard questions, we're going to look at a practical use of prime factors. We're going to find the highest common factor of some numbers and the lowest common multiple of some numbers. If you're not sure what highest common factor and lowest common multiple are, or even factors or multiples, before you watch this, why not go and look at the factors and multiples videos for more detail. So, if you want to find the highest common factor of 195 and 182, our first step is to find the prime factors of both numbers. So for 195, I can see it ends in a 5, so I can divide it by 5. And 195 divided by 5, well, 100 is 25s, so 200 would be 45s, and this is 5 less than 200. So it won't be 45s, it'll be 39 5s. Hopefully, you could use a bus stop method to work that out. We know that 5, so that part of the tree will stop there, and 39 can be divided by 3. So 30 divided by 3 is 10, 9 divided by 3 is 3, so altogether that will give us 13. Repeat the process for our new numbers. Well, 3 is a prime number, 13 is also a prime number, so we've completed our tree for 195. Now looking at 182 using the same method, we can see that it is an even number, so it can be divided by 2. So half of 180 is 90, half of 2 is 1, so that will give us 91. With 91, it's not so clear. It could be a prime number, so let's test it. So we know we don't need to divide it by 2, it's not an even number. Let's see if we can divide 91 by 3. So we'll start a bus stop. How many 3's fit into 9? 3. Exactly. And then how many 3's fit into 1? 0. Carry the 1. And we can see that we've got a 2-digit number. We're still carrying something, so we are not going to get a whole number, so we can't divide it by 3. I'm not going to try dividing it by 5 because we know that numbers that can be divided by 5 end in a 5 or a 0. So let's try dividing by 7. So how many 7's go into 9? 1. Remainder 2. And how many 7's go into 21? 3. So we have exactly 13. So we can see that 91 is not a prime number. We can split it up into 7 and 13. And if you do get a number where you can't quite remember if it's prime or not, but it looks like it might be a prime, it's odd, it ends in a 1, a 3, a 7, then why not try a few divisions, try a few bus stop methods, and just test it like I've just done there. So 13 is a prime number, finish this tree as well. Now we're going to move on to our second diagram for this question. And it's quite a long question, but it will be worth quite a lot of marks. We're going to draw something called a Venn diagram. That means we're going to have a circle representing 100, and we're going to have a circle representing 102, overlapping like this. The factors from the two tree diagrams are going to go into the Venn diagram because both trees have 13. 13 is going to go into the overlap in between the two circles. Now 195 has got a 3 and 182 doesn't, so that 3 will also circle representing 195, and 5 also is only in 195's tree. 2 is only in the tree for 182, so that will only go in 182's circle, and the same for 7. And we've finished our Venn diagram. Now, using this diagram, we can find the highest common factor and the lowest common multiple. So, the highest common factor is all the numbers in the overlap multiplied together, and we only have one, it's 13, so our answer is 13. If we wanted the lowest common multiple, then we're going to multiply all of the numbers in the diagram together, so we would do 2 times 3 times 5 times 7 times 13. Now, the questions ask for the highest common factor, so I'll leave lowest common multiple there and not have to get the answer to that. And I'll write in highest common factor of 195 and 182 is 13. Now, as you can see, I've used up the entire space of the screen to do this question, so I'll clear the screen and then we'll move on to the next question. So now for question 2, we want to find the prime factors of 180 and the prime factors of 144. And then once we've done that, we'll find a Venn diagram and we'll get our final answer from that. Now, both these numbers are even, and what I could do is divide them by 2 and keep dividing by 2 and have quite a long tree and get to our final answer. But I'm going to try a shortcut because I want to avoid the amount of working out we've been doing. So divided by 2 is nice and safe, but with 180, because it ends with a 0, it can be divided by 10. And 10 times 18 would be 180. And neither of those are prime numbers, so we're going to repeat the process with both numbers. So 10 would be 2 times 5, and 18 would be 2 times 9. We'll have a look for prime numbers. So we have 2 is a prime number, 5 is a prime number, and the second 2, of course, is a prime number. 9 isn't, and 9 can be split up into 3 times 3. Now, what this does is, if you start off with a larger number, it tends to make the tree a little bit shorter, and it tends to be a little bit less effort. But if you did divide by 2 and add 2 times 90 and work from there, you would get exactly the same answer. I'm going to do the same thing for 144, and while a safe method would be divide by 2 quite a few times, you should notice that 144 is a square number and it is 12 times 12. Again, neither of those are prime numbers. 12 would be 3 times 4, and the second 12 would also be 3 times 4. Looking for prime numbers, we have the 3's, but 4 can be split up into 2 times 2. and both 4s will give us the same tree. 2 is a prime number, and so our diagram. Build the Venn diagram. First, I will look for numbers that are in both diagrams. So just look at the prime numbers. They both have a 2. So 2 will go in the overlap. They both have a second 2. So a second 2 will go in the overlap. And then 180 doesn't have any more 2's, but 144 has got 2 more 2's. So they will have to go in the circle representing 144. You'll notice I'm crossing numbers out as I go. That just make sure I don't leave any out or count any twice. Moving on to the 3's, both diagrams have got a 3. That will go in the overlap. And both diagrams have got a second 3, which will also go in the overlap. Now we have one number left, the 5, in 180's tree. So that will have to go in 180's circle on its own. So now for our answer, the lowest common multiple would be all these numbers multiplied together, but we are actually finding the highest common factor, and that is the numbers in the overlap multiplied together. So that would be 2 times 2 times 3 times 3. So we'll work this out one step at a time. So 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. So the highest common factor of 180 and 144 is 36. Moving on to question 3, we're going to find the lowest common multiple of 160 and 150. So again, we're going to do 2 tree diagrams, and I could divide 160 by 2, but I can also see that I can divide it by 10. So 16 times 10 will give me 160. Neither are prime numbers, so we'll move on to 16. 2 numbers which multiply together to make 16. So 2 times 8 will make 16. Then I want 2 numbers which multiply together to make 10, and that would be 2 times 5. I can now spot some prime numbers, so we have the 2, 2, the 5, so branches are going to finish. Then looking at the 8, that would be 4 times 2, 4 would be 2 times 2. And now every branch has a prime number. Now looking at the tree for 150, again I could divide by 2, but I can also see that I could divide by 10. So 10 times 15 will make 150. Neither are prime numbers, so we'll repeat the process. 10 is 2 times 5, and 15 is 3 times 5. All 4 branches are giving me prime numbers, so we're at the end of this set of diagrams. Now I'm going to draw my Venn diagrams, so I'll have a representing 160, and I'll have a circle representing 150. First, we'll look for prime numbers that are in both diagrams. So both diagrams have a 2, which will go in the overlap. Both diagrams have a 5, which will go in the overlap. And I can't see any more numbers which are in both diagrams. Now 160 has got 1, 2, 3, 4 2's extra. So I'll write the 4 2's in the part of the circle. That's 160. And 150 has a 3 and a 5, so they'll be written in the part of the diagram that only represents 150. The highest common factor is 2 numbers in the overlap multiplied together, which would be 10, but we actually have been asked to find the lowest common multiple, which is all of the numbers multiplied together. Now, multiplying all these numbers, 8 numbers, is going to take me quite a while, so instead I'll write it in index form. We have got 5 2's, so 2 to the power of 5. We have got 1 3, and we have got 2 5's. And then if you wanted to work out the final answer, something this long would be a calculator question, and we can type this calculation into our calculators. So 2 to the power of 5 multiplied by 3 multiplied 5 to the power of 2 is the lowest common multiple of 160, and 150 is 2,400. Moving on to question 4, we have 182 and 140, lowest common multiple of those two numbers. So first, we're going to draw a tree diagram for each. 182 is an even number, so it can be divided by 2. Now, 180 divided by 2 is 90. 2 divided by 2 is 1, so that will give me 91. Now, I remember 91 from a previous question today, and that was just got to show the more practice you do maths, the more patterns you start to see, the more facts you start to memorize, and the faster things go. All three of these are prime numbers, and 7. Moving on to 140. Again, I could divide it by 2, but it ends at 0, so I can also divide it by 10. So 10 times 14 is 140. 10 isn't a prime number, it is 2 times 5, and 14 isn't a prime number, it's 2 times 7. However, now all 4 ends of the branches are all prime numbers, so the tree is finished. Now we'll draw the Venn diagram, so we'll have a circle representing 102, and overlapping with that we'll have a circle representing 140. We'll start with finding prime numbers which are in both trees. They both have a 2, so 2 will go in the overlap, and they both have a 7, so 7 will also go in the overlap. There's no other numbers that are in both trees, so 182 has a 13, which will go in the circle only representing 182, and 140 has got a 5 and a 2, that will go in the part of the circle only representing 140. Highest common factor is the two numbers in the overlap multiplied together, so 2 times 7 is 14. However, we're not finding the highest common factor, we are finding the lowest common multiple, and that will be all the numbers in the diagram multiplied together. So 13 times 2 times the 7 times the 5 times the 2. And again, with this many numbers, it's going to be a calculator question, so we'll type this into our calculator. So 13 times 2 times 7 times 5 times 2 will give us 1,820. So the lowest common multiple of 182 and 140 is 1,820. Moving on to our final question, we have 185, we have 170, and we are finding the lowest common multiple of these numbers. So starting with 185, I can see it ends in a 5, so I can divide it by 5. I'm not 100% sure what times 5 will give me 185, so over at the side I'm going to start a bus stop method. So we have 5, 185. So how many 5s fit into 1? 0. Carry the 1. How many 5s fit into 18? 3 5s is 15. Carry the 3 to get to 18. And how many 5s fit into 35? That would be 7. So our answer is 37. Now, 5 is a prime. 37 is the kind of number that looks like it might be a prime number. So again, we'll do a check. So I know I can't divide it by 2 because it isn't even. We could try dividing it by 3. So 37 divided by 3 in a bus stop method. How many 3's go into 3? 1. How many 3's go into 7? 2. And we have a remainder 1, so that's going to be a decimal number. It can't be divided by 3. I know I can't divide it by 5. It doesn't end in a 5 or a 0. So let's do for our last check, can we divide it by 7? So write out a bus stop method. How many 7's go into 3? Well, 0. How many 7's go into 37? And we've come across a question now where bus stop method isn't going to help us, unfortunately. So if you're not sure about this, you'll have to resort to counting on your fingers. Let's go through the 7 times table. So 7, 14, 21, 28, 35, which is quite close, and then 42. So because we've missed 37, it's not going to be divisible by 7. So 37 is going to be a prime number. Now, I could have referred to my memory, I could have referred to a list of prime numbers, but I'm just trying to show you, if you're not too sure, do actually check the divisions and see if these numbers can be divided. Now looking at 170. Again, I could divide by 2. Now I have been saying, oh, it ends with a 0, let's divide by 10. But I think this time I will divide it by 2. I'll just show you what happens if you don't try and take any shortcuts and you do keep dividing by 2 if you can. So 100 divided by 2 is 50. 70 divided by 2 is 35. So 50 and 35 is 85. 2 is a prime number. Now looking at 85, I know I could divide that by 5. Now 40 is 10 fives, 80 is 20 fives, and it's 1 5 extra, so that'll be 20 fives, and 5 is a prime number. Now looking at 21, that will be 3 times 7, and both of those are prime numbers. So that's the end of our tree. Now, if you look back at the previous questions we did, where we divided by 10 first, you'll just notice this tree is a little bit longer, so there's less space for your Venn diagram later on. So it's always recommended, if you can see things like divide by 10, try and divide by a larger number if you can. So let's move on to the Venn diagram. We'll have a circle representing 105, and we'll have a circle representing 170. First, let's look for prime numbers that are in both trees. Both trees have a 5, so that will go in the overlap. No other numbers are in both trees, so 37 will be on its own in the 185 circle. 2, 3, and 7 will be on their own in the 170 circle. So now to find the lowest common multiple, we are going to multiply all the numbers together. So that will be 37, 5, 2, 3, and 7. On a calculator, this will give us 37 times 5 times 2 times 3 times 7 is 7,770. So the lowest common multiple of 185 and 170 is 7,770.